Hello and welcome to another video for Year 12 A-Level Maths in Edexcel course, and this time I'm going to discuss Chapter 10 of the Applied Maths, which is Forces in Motion in Mechanics. What we're going to do in this video, guys, the plan would be I'll go over all the things you need to know, then we do some exam questions. We'll leave textbook questions for you to do because you have solution banks for them, so we do some exam questions based on all the knowledge you have acquired. Okay, so first thing I would like you to understand, what are the forces and what effect do they make? I'm pretty sure you have your knowledge from your GCSE maths. The forces, if they are unbalanced, they cause motion. That means things move when forces are acting on them. When I say move, they can move in one direction, they can move in some other direction, they can be pulled up, they can be pushed down, but there is definitely movement if there are forces. And what happens, guys, if two forces are acting in opposite direction and they're equal, then you result into a situation which is equilibrium. What does that mean? The net force in any direction is zero. Simple example, if there is an object and somebody pulls it with a force of 10 Newton, and there's another person who comes, he doesn't want this object to be moved, he pulls it back in force 10 Newtons and there will not be any movement. So this is a situation of equilibrium. Right, so another thing, guys, which you need to understand, what is the type of forces, and the only type of force I want to discuss here is reaction. What does that mean? If you put object on a table, so what happens? There is a weight attached to this object that will always be acting downwards. But why is this object not falling down due to this force? Because the table exerts an equal and opposite reaction in the other direction. Okay, so we'll discuss some of the things later, but important thing which I would like you to know is, ladies and gentlemen, this is Newton's second law. Okay, in the textbook it is called the motion due to force, and it says F equals ma, where every these letters have the obvious meanings. F is the force, m is the mass of the object, and a is the acceleration produced by this force due to motion, guys. What I would like to do, I would like to modify it slightly, and I write down F net equals ma. Means what? F net is the force in the direction of motion, take away total force against the motion. It's really important you understand this, even if you don't like to use the word F net. This is what the book mean as well when they say F equals ma. You're going to be writing down the forces in the direction of the motion, then any force, any resistance which is against the motion, you take away the two to find the net force before you put this m equals ma into it. Okay, so we will now have a look at few questions, the simple ones first, then we move on to some exam style questions. Thank you. I might pick up a couple of questions from the book for the simple ones. Yeah. All right, let's consider a horizontal motion question. This is an object being pulled by two forces. 10 Newtons is going in this direction, 2 Newtons is going in this direction, and we can see very clearly if there's no other force acting, ignoring all the other forces, guys, this object is going to move in this direction. Really important. I would like you to understand this, that you will put the acceleration, the double arrow, always in the direction of the motion. This object is going to go towards right. So Newton's second law in here, That's what I write. Newton's second law for this particle is 10 newtons is the force in the direction of the motion. Take away, let's say 2 newtons in the force against the motion. You can do this as well if you want to make more clear. Equals m, let's say this is 10 kgs. I don't know what the mass of the object is. Let's say 10 times a. Solving this equation, you can find the acceleration produced by this motion, by this object. Okay. Now, if the same question, this 10 kg thing is being pulled here by 12 newtons and this here by 10 newtons, ladies and gentlemen, this time the acceleration will be in this direction because this force is more. So how do I write Newton's second law in this scenario? This will be 12 newtons in this direction, in the direction of the motion. Take away 10 in that direction equals 10 times a. So we'll find a from there. This will be something, okay, a is 0.2 meters per second square in this direction. Okay, that's one. Obviously this is fairly simple. I'm pretty sure you can do this. Only thing you have to be careful about is that you have to write down F net. Okay, and the second thing now, forces can be written as factors as well. Okay, so force is a vector quantity because direction do make a difference. So force can be written as a vector as well in ij component. I would always prefer you write that into in this column vector form. That's easier, that's better, that's easy to handle. Alright then, so what we need to do, guys, we're going to be moving on now and doing some questions on a really important part of this chapter, connected particles. Connected particles will be some pulley questions and some car and caravan and so on and so forth. So we work on some connected particle questions from the exam style. I'll go into questions straight away now. Alright, this is the first question in the worksheet which I'm going to attach for this an Edexcel internal review. Okay, obviously this diagram is not very neat, but this is important, people. I would always like you to redraw the diagram because annotation on diagram is really, really important. If you have the worksheet in your hand, obviously you can annotate it on there, right? What is that given? What is given to me? The mass of the two objects. What force this mass is going to produce is the weight. Acting downwards, you know that. So this will be from here, acting downwards, it is 0.4 g. And from B it is 0.3 g. Right, then why are these two objects not dropped down? Because of the tension in the string. And ladies and gentlemen, understand one thing really important. Because this is a single string on both the sides of the pulley, the tension in both the strings will be same. If there were two separate strings, which you will get in some situations, when like say something's hung with the two separate strings, you will have two different tensions here, T1 and T2. So try and understand this. This is important. Single string and tension. Where does tension? It is always acting towards the center of that string. And where is the center? That's where the center is. So it's going this way, it's going this way. Okay, that's how I would like to think. Right. Now what happens, guys? The particles have been released. You're going to first make sure which direction both the particles are going to be moving. This is heavier, so this will tend to go down. So acceleration of this is this way, and acceleration of this is going to be that way. And acceleration is same as well because they're moving as a system. Right. The question asks you to find the tension and find the acceleration. Now, guys, there are a couple of methods of doing this. And in these kind of questions, I would always advise you to look for very carefully two simultaneous equations. Okay, I'll do that. You can find acceleration probably in other ways as well. But I'll do the two simultaneous equations, the standard which I would probably like you to follow for everything. Right, I'm going to write Newton's second law for particle A. Ladies and gentlemen, which direction it's going? It's coming downwards. Any force acting downwards is 0.4 g in the direction of the motion. Any force which acting upwards is t, so that's take away, is equal to 0.4 times a. Now this equation has got two variables, t and a. So I cannot solve this. What do? I try to look for the second equation, Newton's second law for particle B, because there's another particle as well. Which direction this is going upwards. So any force going upwards will be written first, T. Any force which is against the motion is minus 0.3 g is equal to 0.3 times a. Once again, the acceleration, because they are moving as a part of a system, will be same. These are two equations, simultaneously solve them, find the value of a. I'm not expected to do that for you. I'm pretty sure you can. And you can actually find the value of a and t both. That will give you the answer to part 1 and part 2. Okay, now third part is really important. Let me just read this statement to you one more time. Okay, the statement, it says like this. It says, when the particles have been moving for 0.5 seconds, the string breaks. Okay, find the further time that elapses until B hits the floor. Now, really important you understand the situation. What's going to happen for 0.5 seconds, B is going to be moving up and A is going to be moving down. So B will be slightly more higher position than 1 meter from the ground, and A will be closer to 1 meter towards the ground. What they ask me to find, when string breaks after 0.5 seconds, how much further time when B hits the floor. Why would B hit the floor? Is because when string breaks, there won't be any tension. So the only force acting on B in that case is the weight coming downwards. That is going to bring it down. So you're going to find the time. We use UVAT for that. It will be a freely falling body. Okay, the acceleration will not be the acceleration which we found in the first two parts because tension is gone. So we need to work out how much time does it take as a freely falling body coming downwards. Okay, think about it and we'll work together in about a few seconds. You can pause the video now, people, and try and work it out. Okay, take onus of responsibility of your learning on yourself and do not look at the video until you've tried it. Okay, then I'm putting this in the calculator or working out without calculator, guys. I've got these two answers. Let's work together on this question now. After moving from this position, let's say B is here at that position after 0.5 seconds. Let's call this position C, just for the argument's sake. Okay, ladies and gentlemen, can we find what will be the velocity of particle B at C? What's happening? It's moving with the constant acceleration. Initial velocity was 0. Okay, A is 1.4 and T equals 0.5. So V equals U plus AT, which gives me U is 0. So this is 1.4 times 5. So it is 7 meters per second and it's going upwards. Okay. Second step, can we find how much distance has it traveled in this time? So how do you find the distance, guys? Let's do UVAT again. Let's see, what do we have? This basic standard for distance is what we need to find. U is 0. Okay, and V we found already is 7 and T is 0.5. Can we use these? Okay, we can use this as well. Many equations we can use. What's the equation for this, guys? If you remember, S equals U plus V over 2 times T. So S equals 7 over 2 times 0.5. So 3.5 times 0.5, S equals 1.75 meters, I think. Okay, obviously you could have used A as well and use S equals UT plus half AT square. I thought this was slightly more easier. So you got S as well. So this distance we know. Now what do we need to do, people? What do we need to know? That B has to fall down from that distance. Okay, so let's work that out using UVAT of the previous chapter. Yep, so let's write down. Let's arrange it for me, please, people. UVAT. In the last situation, write down what these things you have and which formula you're going to use. Okay, before that, I've just realized, people, that's why I just commented slightly earlier that this is 1.4 times, it should be 0.5 there. So that should be 0.7 is the velocity. This is 0.7, then that should be 0.175 meters. Okay, so what do we have, people? 0.175 meters coming downwards. Okay, if I take everything going upwards as positive, this is my general sign convention. You can do whatever you want. Okay, so freely falling, so A is minus 9.8 because it's coming down. S is coming down, so it's negative as well. Okay, U is the initial velocity, which was this one, that is 0.7, and it's going up, so I'll take this as positive. Okay, and time is what I have to find. Right, guys, if you in this situation, let me use different color pen. If you want to look once again with the red color I've written down, which I normally take, going upwards as positive. If I had to come down and I take this as positive, sorry, not so, then this would be positive in that case. That will be positive. This will be negative in that case, the velocity, the initial velocity, and this will be positive as well. So it doesn't matter, you took whatever. I would probably prefer that you keep only one sign convention. Okay, the formula now, SUANT, S equals UT plus half AT square. I'll put the values in. Minus 0.175 equals 0.7t, because I'm taking this as positive, because it's going upwards. Okay, plus half is 0.5, so 0.5 times minus 9.8 and times time is what we have to find. Thank you. Minus 9.8 t squared, guys. This is a quadratic equation which can be further written as 4.9 t squared. I brought that term into this side, minus 0.7 t and minus 0.7175 equals 0. So solve that quadratic equation using calculator and work out the answer of t. I'm pretty sure one of the t would be negative, one of the t would be positive. You cannot take the negative t. Right, this is one of the questions. I do one more, then we leave rest to yourself. Alright guys, now we're going to do a question on horizontal motion. I'm going to read this out to you. It says a car which has run out of petrol is being towed by a breakdown truck along a straight horizontal road. This truck has mass 1,200 kgs. Let's draw a little diagram, which is modeling is really important. Okay, let's say they're both going in this direction. Okay, so this is the truck, and behind it somewhere is the car. So that's car, this is the truck, and there's a rope in between. Okay, so mass of the truck is 1200, and the car has the mass of 800 kgs. Okay, right, and then it says the truck is connected to the car with a horizontal rope, and truck and inextensible, that has to be standard. The truck's engine provides a constant driving force of 2400. There is a force which is being applied in the direction of the motion by the engine, which is 2400 newtons, and this being applied only on the truck. So that's where it is, guys, 2400 newtons. Okay, and the resistance to the motion of the truck and the car are modeled as constant in a magnitude of 600 and 400. So there's a resistance here on the truck, 600 newtons, and on the car there's a 400 newtons. Okay, so find the acceleration of the truck and the tension of the rope. Okay, let's work on this first. All right, guys. Now, truck is engine applying a force on the truck. Why is car moving then? What is pulling the car is the tension between the rope, which is acting towards the middle of the rope, people. Okay, now to find the acceleration, if I take the whole system together, on purpose I am going to do this question slightly differently from the first one. You could do, by the way, the same method which we did in the first one. You could make the two equations. Let's do both the methods here. Okay, step one, taking whole of the system together. what happens, people, then in case ignoring this force of tension, because these two forces are cancelling each other. This is tension going in that direction, this is same tension coming in this direction, cancelling each other. Okay, so the total mass of the system is 2000, I hope it's 800, I've copied it right, 2000 kgs. Okay, the net force in the direction of the motion, which is that way, you can see I can make the acceleration going in that direction, is 2400 going in this direction, take away 600 going in that direction, that resistance, take away 400 going in that direction as well. So ladies and gentlemen, Newton's second law for the whole system. Okay, that comes out as what? This is 2400 take away 1000 is 1400 is equal to, acting in this direction, is equal to mass, which is 2000 times A. So we find A from here. I think it is what? 0.7 meters per second square. Okay, now what do you do from here, guys? You can take Newton's second law for any of the two bodies. Let's take for car, just for the sake of it. Okay guys, let's make the diagram for car there. What are the forces acting on it? There's a tension in this direction, there's 400 newtons in this direction, and the acceleration of A is 0.07 in that direction. Oh, I've done my calculation right, I think it is. Okay, Newton's second law, force in the direction of the motion, T, take away force against the motion, 400 is equal to mass of the car is 800 times by 0.7. Okay, we can find T from here. If I do, this is 560, so T equals 960, I think. Okay, check my calculations. Okay, the second way, these are the first two parts of the question which give you 6 marks. The second method, which I said you could have done in every question, guys, the simultaneous equation. Let's see Newton's second law for the truck. Okay guys, truck, we're going in the right direction, so 2400 take away 600, take away T. Can you see the T is also, if you're now looking at truck alone, this is the force in the direction of the motion, this is the force against it, this is the force against it. Okay, is equal to the mass, which is 1200 times A. So actually we finally get 1800 minus T equals 1200 A. That's your one equation. Then Newton's second law for the car, we're looking at only car, people. Okay, so these are the forces we're looking at now. This will be T, force in the direction of the motion, take away 400, forces against the motion, equals the mass 800 and times A. These are two equations. You solve them and work out the answer. You shall get the same answers, I hope, if my calculations are right. Then guys, let's read the next part of that then. Right, the question goes like this. It says, when the truck and the car are moving at 20 meters per second, so velocity is 20 meters per second, the rope breaks. It's similar question to what we've done before. The engine of the truck provides the same driving force as before, but this time it is only pulling the truck. Car is not being pulled anymore after that. The magnitude of the resistance to the motion of the truck remains 600 newtons. Show that the truck reaches a speed of 28 meters per second, approximately 6 seconds earlier than it would have done if the rope had not broken. Brilliant. Okay, let's say how much time truck would take if the rope was not broken to reach a speed of 28 meters per second. Okay, its constant acceleration, u at. Okay, so speeds given to me is 20 initial, 20 final, we want to make it at 28. Acceleration is 0.7 and we can find the time. Okay, let's work it out, people. Let me leave that to you. Work it out. We'll work out the answer. How much time does it take when the rope was not broken? Okay, work that out for me, please. Thank you. Okay, I'm pretty sure you figured it out. This is one of the easiest one. V equals u plus at. So T equals V minus U over A, which is T equals 8 over 0.7, and which is, I would leave it in fraction. This is 80 over 7 seconds. T is 80 over 7 seconds. Okay, we can figure it out. later on how much is that. Right guys, what happens when the rope breaks? Because all the force is now only being used for truck, the truck is going to accelerate faster. So let's find the new acceleration. Okay, how would you find the new acceleration? Write down the equation of the motion of the truck all over again without the tension, because when the rope is breaking, the tension will go. What does that mean, people? The truck this time is, this is the 2400 newtons and this is 600 newtons. That's the only resistance we have, and acceleration is in this direction. Okay, so Newton's second law, 2400 take away 600 equals 1200 times the new acceleration, and that is 1800 divided by 1200. The new acceleration is 1.5, I guess. Okay, so you can clearly see it's going to take lesser time because acceleration is almost doubled. Okay, now you're going to use Suvet to find the time taken in this scenario. Can you do that for me, please? Similar to what we've done over here. Okay, so what I got is 16/3 seconds now for it to reach there. This was the original time. Let's find out the difference. So 80/7 take away 16/3. I think this should be closer to 6 seconds, which they're looking for. All right, ladies and gentlemen, I finished this with this, and I'm going to attach the worksheet and you can do some questions yourself. If there's an issue, we can discuss it later. Enjoy learning, everyone. This is once again my attempt to year 12, chapter 10 of applied forces in motion, and especially the connected particles bit. Bye bye.